Hello everyone, today we are going to talk about our project which is named by Electric Cargo Tricycle. Our team members are myself, Şevket and Alperen. These are our topics, so let's start. In the beginning, we want to produce a tricycle which is used for cargo job, likewise short distance and carry light duty. For in small areas like university campuses, villages, military areas and hospitals. For this purpose, we select some objective. These are pedal assist drive and ergonomic design. When we check the market, we decide to make a feasible product. And then we list technical requirements. These are mechanical, electrical, and user requirements. So far, these requirements we made gold and detect effective restrictions. Our goals are make system hybrid drive, ease and fast transportation in Davutpaşa campus, make suitable for both genders and age. Our restrictions are motor type and capacity, or speed limit, and tricycle body angulation limitations. So start to implementation. First, we determine our mechanical needs. For of the health result, we defined our parameters are highest value. This means maximum load. First, we get our force, then get our power need, and check to match situation of our electric motor. For maximum condition or motor, nominal power is not enough, but maximum power is acceptable. Because of that, we keep use our motor. Then we designed our powertrain system based on our motor and our motor produced nominal torque, and it is very good for our system. Then we checked our motor and battery capacity. Our riding capacity is acceptable for using. After we checked our tricycle body durability, we checked the stress and possible displacement and ensured that there were no chronic errors in the body of the project.
The dynamic system of the Tricycle was modeled on MATLAB Simulink. To map the desired route, the GPX file that includes the GPS data was converted into MATLAB workspace, and slopes and distance were also calculated to get better results. The BLDC motor model only activated when the cadence increased by 20% to give support to the rider. And energy consumption was also calculated by ampere counting method. Systems block diagram. System powered by 48 volt 11 ampere hour battery. And to communicate, here's our system diagram. 48 volt battery powers up the whole system. And we put a switch between battery and controller to save the battery and prevent the sparks because of the high voltages. We use an Arduino to display information on LCD display and process the feedback comes from sensor to send the motor driver to give the motion to motor. The pedal assist system. The path sensor we used is an epoxy encapsulated circuit with a Hall effect device and transistor output. The sensor pulses a signal which toggles between high voltage and ground when the device senses a magnetic field. The result is a digital signal that varies in frequency with the rotation speed of the disk carrying 12 magnets. The signal goes to Arduino and assigned as a variable to clarify our set points. The main goal is the setting RPMs of the two rear wheels, that one is driven by user and the other one driven by chainsaw that's used by the motor itself. To give the tricycle a balanced and safer ride. In order to adjust the engine motor speed to reach the set points, Hall sensor is used by the wheel because of lack of the encoder. Motor speed also calculated with respect to gear ratio to get precise results. Several wells were generated and PI control was designed to control the motor precisely. In the first test, motor speed were stayed under the set points after tweaking Kp and Ki parameters to reach the set point. The ride was pretty smooth enough to travel around. Tricycle can also move in all-electric mode. The throttle was implemented for this reason in choice of rider. It can climb up hills without spending additional energy. It is directly connected to the controller since it has a microcontroller inside. It is suitable for implementing a code. Inside the code, PWM values were calculated with respect to operating voltage to control the motor speed, as shown in the figure. We designed a speedometer to monitor the RPM and speed. The hardware setup for this project is very simple. The Hall sensor is a 3-thermal transducer that changes output based on the magnetic field around it. It's commonly used for speed detection and proximity switching. The permanent magnet attached on the wheel and the Hall sensor placed near the magnet to detect magnetic field whenever a magnet passes by. It can detect it. The Arduino detects the voltage change through its interrupt pin and determines whether the magnet is near the sensor or not.
Let's look at our implementation. These are electronic circuit construction and our motor chain set. Here is a welding operation and finally assembled product. This is our list of budget. Lastly, look our working schedule. And thanks for your attention. Have a good day.
Hızlan. Çok iyi gidiyor. Çok iyi. Hiç pedal çevirmeden. Tamam. Bekle, yetişeyim sana. Sol. Devam et. Tamam. Bir tur daha, azıcık daha bassana bir. Çekiyorum, hatta şöyle çekeyim. Bas gitsin, bas. Tamam, gidiyor. Gayet tatlı gidiyor. Çıkar mı? Çekiyor şu an. Tamam, çekildi. Burada şey görülmüyor, kadans. Bırak motorla git sadece. Bırak motorla git.